Hello everyone, this is Jyoti Kati from ENC department BGMIT Mudor. We are going to see the DSP lab experiment. That is on the second experiment is linear convolution of two given sequences. Then we have to verify the commutative, distributive and associative property of the convolution. Next, the aim of this experiment is you have to write the program in Skylab code and perform the linear convolution of two given discrete time signals with its properties. Then theory for this already you are knowing. Once again I will explain this how the convolution will takes place. Convolution is an integral concatenation of two signals. It has many applications in numerous areas of signal processing. The most popular application is the determination of output signal of the linear time invariant system by convolving the input signal with the impulse response of the system. Then convolving two signals is equivalent to multiplication of two Fourier transform, two signals, okay, Fourier transform of those two signals. That means convolving two signals in time domain is equivalent to multiplying its Fourier transform signals. Then the formula is already you are knowing. In a continuous time signal, the convolution, linear convolution formula is this, that is x of t convolved with h of t is equal to integration from, integration limits are from minus infinity to infinity, x of tau into h of t minus tau with respect to tau. Then similarly, in case of discrete time signals, the formula is x of n convolved with h of n is summation x of m h of n minus m. Here x of n is the input signal and h of n is the impulse response of the system. Then the linearly convolved signal, that is output of the signal, the length of the output signal here is, that is length of y of n. Y of n is the output signal. Y of n is equal to length of x of n plus the length of h of n minus 1. Okay, this is the theory regarding this. Then how we'll do the convolution in discrete time signal? First we'll take the reverse of h of n signal. H of k is, if suppose h of k is the impulse response, reflection of this signal is nothing but folding the signal. We'll get h of minus k. Then folded signal will shift. Okay, folded signal will shift. Then we'll get h of n minus k. Then what we'll do, we'll element wise multiplication of the sequence h of k, x of k with h of n minus k. Multiply x of k with h of n minus k. Then we'll take the summation of product sequence h of x of k, h of n minus k, resulting in the convolution value of y of n. That means in convolution we are doing 4 operations. One is first we'll do the reverse of h of k, that is folding the signal. Then we'll do the folded signal will shift. Second operation is shifting operation. Okay, then we'll get h of n minus k. Then we'll multiply each value of h of n minus k, we'll multiply with x of k by varying the value of k here. Then multiplied, all the multiplied values will take the summation of that. Therefore, we are doing 4 operations in the convolution. First is reflection, shifting, then multiplication, then the summation. This is the theory regarding this. Then we'll go to the next part, the programming part. Okay, I'll go to the Skylab first, then I'll explain the programming part there itself. Okay, you have to type the program for the linear convolution in the Skylab window, editor Skylab window. There you have to type the program first. Then see here, I'll explain about this program, how it will work. CLC, clear, close, already you are knowing. In the previous videos I explained what the CLC will do, what the clear will do, and what the close command will do. Next, what he'll do, x is equal to input, enter the input sequence. Here he'll enter the input signal x of n. Next, m is equal to length of x. M, it will store what is the length of x. Okay. Suppose if we'll take x of n is equal to, I'll take it as 1, 2, 3 and 4. I'll take this as a x of n signal. This is input sequence. Then m will store, m is equal to length of x. How many samples are there? Here 4 samples. Then m is equal to 4. Next, Lx is equal to input, enter the lower index of input sequence. That means where the x of n signal will start, whether it will start at 0 position or it will start at -1 position or it will start at 1. That we need to display. Okay, you have to enter where is the lowest sample it will start. That means suppose I'll take Lx is equal to 0. That means the x of n will start at 0th position. Okay. Next, h of x is equal to Lx plus m minus 1. That is h of x is equal to Lx. Your Lx value is 0. Then m value is 4 plus 4 minus 1. Then h of x is what? 3. Then n is equal to, your n will vary from Lx. Lx is 0 in steps of 1 up to hx. Hx is 3. That means your x of n value will start at 0 and at 3 in steps of 1. Okay. Similarly, you have to do for the next sequence, that is the impulse response. That is h of n is equal to input, enter the impulse response of the sequence. Suppose I'll take impulse response h of n is equal to that, also I'll take it as 1, 2, 3, 4. We can take any signal. I'll take for example here 1, 2, 3, 4 only. Then what is L in the program? Next part is L is equal to length of h. Length of h is what? How many samples are there? 4 samples. That means L is equal to 4. Next, you need to enter the lower index of impulse response. That means where the h of n will start. Here LH also I'll take it as 0. That means it will start at 0th position. Next is HH. HH is equal to LH. LH value is 0 plus L, that length of h of n, 4 minus 1, that is equal to 3. Ending limit is 3. Therefore, lastly what you are seeing here, G is equal to, okay, now G is equal to, what is the limit for G? G is equal to LH. LH value is 0 in steps of 1. HH. HH is 3. That means h of n value will start at 0, end at 3 in steps of 1. 0, 1, 2, 3. It will take the samples, 4 samples. Then next sequence, I have taken the third sequence also, because we need to verify the properties. For verifying the properties, we require 3 signals. Therefore, third signals I also taken. Z is equal to input, enter z of n. Okay, z of n, whatever value will take, enter that value. Okay, I'll take z of n value. Next, I'll take it as any value you can take. For that, it will calculate the linear convolution of the given sequences. Suppose I'll take z of n also, z of n value also 1, 2, 3, 4 only. That is the third sequence. Similarly, you have to calculate what is its length. P is equal to length of z, P is equal to 4. Next, Lz is equal to enter the lower index of h of n, means z of n where it will start. Here also I'll take, suppose I will take different value. Now the z of n will start at -1. Zeroth position is here. It will start at -1 position. -1 position, its amplitude is 1. Okay, next. Hz is equal to Lz. Lz means -1 plus P is 4 minus 1. Then what is its value? 4 minus 1 means 2. Okay, that means z of n will start at -1 position and at 2th position. Okay, therefore what I have written, S is equal to Lz. Lz value is -1 in steps of 1, ending value Hz. Hz is 2. That means -n it will start and at 2 in steps of 1. In steps of 1 means it will starting at -1 means -1, 0, 1, 2. Okay, it will start at -1 and at 2 like this. Now you have taken all the 3 inputs. For next, what you have to do for the output signal, that is convolution of x of n with h of n, what is its starting and ending limit, that you have to calculate. Here it is calculated. Here nx is equal to, okay, nx is equal to Lx plus Lh. Lx value is starting at whatever previous value you are taken, that Lx it will take plus Lh. Okay, now Lx we have lower index what you have taken for the input signal, you have taken as 0. Then plus Lh. Okay, Lh what you have taken, that is lower index for impulse response, that also we have taken as 0. That means Nx value is 0. Next, Nh is equal to, okay, this part, Nx is equal to, Nh is equal to Nx. Nx plus m plus 1 minus 2. Okay, that is the output value of your output response. What is the output position of output sample? Okay, ending point of the output y of n. Previously you have calculated Nx, that value you substitute here, m also you have calculated, that you substitute and calculate the Nh value. Okay, from these two steps you'll get what is the starting value of the output y of n and what is the ending limit of the output y of n. Then you have to calculate the convolution. Okay, convolution is, here inbuilt symbol we'll use predefined symbol or predefined instruction is for Skylab, it is used as convol. Okay, this is a predefined function. Y is equal to convolution of x with h. It will do the convolution of x with h. Then display DISP of y. Okay, output response. It will display the convolution of x with h. Y it will delay. Convolution of x of n and h of n, what you'll get, that will be displayed as y. Okay, then its limits. Y of n, what are the limits? You already calculated. N of x, nh. Okay, therefore R is equal to, it is the position of output sequence, means it where it will output will start and where it will end. It will start at nx and at nh. Then how to display these input sequence as well as the output sequence? For that we are using the figure 1, subplot 1 comma 1 comma 1. Okay, subplot means 3 means there are 3 rows, 1 means 1 column in that first figure. Okay, 3 rows you'll get, first only 1 column in that first figure. First figure will indicate the input x of n. Here this a is equal to gc of a, x location, y location is equal to origin, means it will start, x-axis and y-axis will start at origin position. Then it will plot 2D 3 means it will plot the x input, x of n input for by varying the n value. Then we'll display x of n, x label, y label, title of that graph. Similarly for subplot 3 comma 1 comma 2. Okay, second figure. For the second input h of n, it will plot the graph for h of n. Whatever the values you are given, depending on that, it will plot the graph. Then similarly, what is along x-axis, what is along y-axis, and what that figure indicates, and that is the impulse response figure. Therefore, you have to give the title. Okay, in first two, your diagram for input sequence h of n and x of n. Then the third diagram we are drawing for the output y of n. That is convolution of x of n with h of n. Therefore, subplot 3 comma 3, that is third figure, that is the output value. Here also x label, y label, and the title. X label, as I told, it is what is along x-axis, what is along y-axis. Y label means title means what that graph indicates, what that third figure indicates. Okay, this is about the convolution. Okay, we are done the convolution of two signals, x of n and h of n. Then we need to verify the properties also. What are those properties? That is associative property, commutative property, distributive property. Okay, what is commutative property? Commutative property, as you are knowing, it is x of n convolved with h of n, that should be equal to h of n convolved with x of n. This we need to verify. Next, similarly you have to verify associative property. Associative property is x of n convolved with h of n, that is convolved with z of n. Okay, convolution of h of n with z of n, whatever you'll get, that should be convolved with x of n. This should be equal to x of n convolved with h of n. This whole thing is convolved with z of n. If these two are equal, LHS is equal to RHS means the associative property verified. Similarly, last property is distributive property. Distributive property, that is x of n, it is if it is convolved with h of n plus z of n. Okay, this LHS part should be equal to x of n convolved with h of n plus x of n convolved with z of n. These three properties we need to verify. See here what I have done. First I verified the associative property. What I have taken, B is equal to convolution of y and z. B is equal to convolution of y and z. Okay, you can take any variable. I have taken x, z and h. You can take any variable. Okay, here I convert B is equal to convolution of y and z. Then C is equal to convolution of h and z. Okay, that means what you have done here, B is equal to convolution of y and z means y already you got it. Y is nothing but what? Y is equal to convolution of x of n with h of n. Previously we have done that convolution. This should be convolved with z of n. That is B. That will be stored in B. Then C is equal to convolution of h with z. Okay, first you have to do the convolution of h of n with z of n. This whole thing is convolved with, that C part is convolved with x, will get D. Then what you have to verify, if B is equal to D, B part is nothing but this. B is this part and D part is this one. If B is equal to D, then it will display the associative property is verified. If B is not equal to D, then it will display as associative property is not verified. Okay, this is about associative property. Next, commutative property. again taken a different variable q is equal to convolution of h and x, because in commutative property what x of n convolved with h of n already you have done here previously convolution. What you have to do, you have to do convolution of reverse h of n with x of n. Therefore here q is equal to convolution of h with x I have done. Then I have compared y with q. Y is nothing previously, or y is nothing but the convolution of x with h. Okay, then q is convolution of h with x. If these two are equal, if y is equal to q, then the commutative property is verified. Otherwise, it will display the commutative property is not verified. Okay, this is about commutative property. Next comes the last property, that is distributive property. For distributive property, first what I have taken, E is equal to h plus z. That means first this part you have to do, h plus z. We need to add these two sequences, h of n and z of n. First I added that and equated to E. Then I have calculated the convolution of x with E. Okay, this x with this E part. That will be stored in F. Next we have to calculate x of convolution of x of n with h of n. That here I is equal to convolution of x with h. Next this part, x with z. Convolution of x with z is g. We need to add these two. That is k is equal to I plus j I have taken. Okay, you will get this RHS part. K is nothing but RHS part. Then your F is nothing but LHS part. If F is equal to K, then the distributive property is verified. If F is not equal to K, it will display as distributive property is not verified. Okay, now I'll execute this program and see how we'll get the waveforms and the output for this. Okay, see here. After executing that program, you'll get enter the input sequence. That means first you have to enter the x of n values. Okay, 1, 2, 3, 4 I have taken as I explained previously. Next, you have to enter the lower index of input sequence where the x of n will start. Position of x of n will start at 0. I have taken it as 0. Next, similarly, you have to write what is the impulse response samples. What are impulse response samples? I have taken as 1, 2, 3, 4 again. Then where it will start? Starting position again I have taken as 0. Next, similarly, what are the z of n values? That also I have taken as 1, 2, 3, 4. Next, lower index of z of n, where it will start. Now I'll take this one as -1. That means z of n will start at -1 position. You can take any values. Next, see. Okay, we got the circular convolution values. The output response y of n is equal to 1, 1, 4, 10, 20, 25, 24 and 60. This is the linear convolution output. Then what it is displaying? Associative property verified, commutative property verified, distributive property verified. Okay, once again I will show the output waveforms. Output, I'll execute it once again and I'll show the output how we'll get. Click on this execute command. Okay, click on S, then go to another window where you need to enter the inputs and where you'll get the outputs. Here I'll take 1, 2, 3, 4. Starting limit is 0. Then another sequence also I'll take it as 1, 2, 3, 4. And that will also start at 0. Then z of n also I'll take it as 1, 2, 3, 4. And it will start at -1. Now I'll Okay, I'll press enter, you'll get the outputs. See. Okay, convolution 1, 4, 10, 20, 25, 24 and 16. Since all the properties are verified, associative property verified, commutative property verified, distributive property verified, then you'll get the graph for this. Okay, this is the output graph for this. Okay, we have drawn for 3 graphs. Input sequence x of n, this one, that is, it will start at 0. Okay, starting position is 0 here because they are giving the lower index as 0. It will start at 0. Its amplitude is 1. Next 1, 2, 3. Okay, it will start at 0. Ending limit is 3. Amplitude is 1, 2, 3, 4, x of n. Similarly, this second graph is for h of n. H of n also we have taken as 1, 2, 3, 4. Okay, and it will start again, it will start also 0. Lower index we have taken as 0. Okay, here along x-axis and y-axis the values are displayed. Then we have taken the graph for output, that is linearly convolved signal y of n. Y of n, what are the values you got it? For those values we are getting the values. For example, what value you got it? Output, what value you got it? You got it for 1, 4, 10, 20. Okay, those values will be displayed there in the graph 1, 4, 10, 20. For 0th position, it will be 1 for 1, 2, 1, 4, 10, 20. Okay, then whatever the next values are there, according to that, we'll get the output. This is the linear convolved signals. Okay, subplot 3, 1, 1 we have taken. That means 3 rows. This is first row, second row, third row, and only one column. Okay, one column. And that first figure indicates x of n, second figure indicates h of n. This is output y of n, that is linearly convolved signal. Therefore, from this experiment, we have done the linear convolution of 2 signals and we have verified the associative, distributive and the commutative properties. Okay, thank you.